name is Sakesh Shukla from Adelaide Engineering College, 9. Today we are going to study one more important topic, that is, so here what happens, the q square b square h square is, we can write it v square, and here 2 will cancel each other, and the final equation is, I can write it, this one is v square, and v square by gh into dh by dx is final what we are started to derive that this one, this v square by 2g, so final minus v square by gh into dh dx, so that value we got it. And next we can next procedures we are written, we'll go for that. I don't have space, I can write it here. Okay, that you can explain it here. Okay. We all know v is equal to q by a is equal to q by bh, so that we written that one, don't confuse it, q square by b square into h square, that we can written is here. Next we know total z plus h plus v square by 2g, total energy line, that we had that equations. So I can write it, total energy line d by dx, and next dz by dx, all I can divide with respect to horizontal unit width unit line, and dh divided by dx plus, we know that one, v square, that one v square, this one we have written that one. So here I am writing here, this one I can write it here, minus I is equal to minus dh by dx, and here we know that value, this one is equal to minus v square, I will just minus v square by dh by dx. So here why I am taken negative, you can take it positive also, this is for small arrangements I have done for easy calculation, so that I have taken the minus IE, so you can take it positive also, so I can write it here, IB I am taken this side, IB minus is equal to dou h x, that one I have taken commons, 1 minus p square by gh. So dou h dou h square is equal to, next I can write it, dou h by dou x is equal to IB minus IE divided by 1 minus p square gh, 1 minus v square gh. Here dou h by dou x is equal to, IB is equal to slope of the bed, this one IB is equal to slope of the bed, this one IB, and IE slope of the energy line. This slope we can call it, this is IE. This one you are calling IE, slope of the energy line, IE, divided by velocity 1 by minus v square gh. 1 minus v square. This is velocity, and this is h is water height. H is water. G is acceleration due to gravity. So what we can write it here? Always, so as we discussed, the open channel flow and by gravity flow. The open channel always flow by gravity. So that gravity is connected to Froude number. So we can write. So it means we can write it gravity, the open channel flow by gravity. So gravity is connected to Froude number. So Froude number concept is very much useful in open channel flow. So Froude number, we know that Froude number is V is equal to root of gh. So V is the velocity and g is acceleration due to gravity, h is height of the flow. So here this is, you can write v square by gh. So f r square, Froude number, if I write it in square, v r square into square will cancel gh. So you can write it dh by dx. It means ನೀರಿನ ಹೈಟ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜ್, ಹೊರಿಜಾಂಟಲ್ ಯೂನಿಟ್ ಚೇಂಜ್ ಆದರೆ, ಹೊರಿಜಾಂಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಯೂನಿಟ್ ಚೇಂಜ್ ಆದರೆ ನೀರಿನ ಹೈಟ್ ಅಲ್ಲಿ ಏನು ಚೇಂಜ್ ಆಗ್ತದೆ, ದಟ್ ಐ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ಹಿಯರ್. ಐ ಬಿ ಮೈನಸ್ ಐ ಇ divided by 1 minus fr square, Froude number square. So we can write it, if that is x direction, what are the changes will happen? If you know, if in the non-uniform flow, if it is x will vary, what is the height? So using this formula we can find it, that one. This is on the concept. So we will solve one problem related to this one, gradual varied flow. This one solved in your textbook also, Module-3, page number 6. That problem is there about the gradual varied flow. Find the slope of free water surface in a rectangular channel find the slope of free water surface in a, find the slope of free water surface in a rectangular channel find the slope of free water surface in a rectangular channel of width 20 meter, comma, the depth the depth of flow depth of flow 5 meter. The discharge through the channel is discharge through the channel is 50 meter cube per second. The bed of the channel having slope of 1 in 4000. Take the value of Church's constant. Take the value of Church's constant. C is equal to 60. Find the slope. Here we need to find the slope. So here the question I will read once again. Find the slope of free water surface in a rectangular channel of width 20 meter. The depth of flow is 5 meter. The discharge through the channel is 50 meter cube per second. The bed of the channel having slope of 1 in 4000. Full stop. Take the value of Church's constant. C is equal to 60. So with their data given, always first you need to write data what they given. So what is the data given? Find the slope of free water surface rectangular channel. Width is B. Width the B is given 20 meter, and the discharge through the depth of the flow H is equal to 5 meter, and the discharge through the channel is Q is equal to 50 meter cube per second given, and the bed of the channel having slope is IB is equal to 1 in 4000, and Church's constant C is equal to 60. First we are having the formula. Step 1, applying the formula, we having the formula Q is equal to V into A. Here they given discharge Q, and velocity we don't know because we are having the Church's constant C is equal to 60, and area we can find out B into H 20 into 5, so that we can find it area. So area is equal to, how we can calculate area is equal to 20 into 5, so it's 100 meter square. That we can write it here, and Q is equal to V into A. C, Church's constant V is equal to, we can write it C root of M I into E. Simple. So how we can find out M? First we find out step 2, find out hydraulic mean depth. So that is M is equal to A by P. So M is equal to A area 100, P is equal to B plus 2D, that we know that one. B plus perimeter, this H, perimeter means wetted perimeter, that two side. So we can write it B plus 2H. So we can write 100 plus B, we can write 20 plus 2 into 5. So we can write 100 divided by 30 is equal to 10 by 3 meter. So next, IE is equal to slope of the energy line. So we need to find out the I this one, V is equal to this one, we need to find V is equal to this formula, we need to find out the I is equal to IE, slope of the energy line. So how we can find out that one? Here I can write I is equal to IE, it means slope of the energy line. So using the formula, we know Q is equal to 50 and 100 area, and C is equal to 60, and M value 10 divided by 3 into IE. So answer is 10, 9, 5, 4.45 IE is equal to 50. I is equal to 50. So IE is equal to 50 divided by 0954.5 square. So answer is 0.000208. This is the final answer. This is the final answer we got using this method. So nothing is there, simple equation. If you know that formula, Q is equal to VEA, and they given the charges constant. So we find it at the I value is that one, IE values we got it that 0.00208, and charges constant we know that C root of mi, velocity V is equal to C root of mi. So instead of V we can write it C root of mi. We need to find out the I value. So find out the hydraulic mean depth. Mean depth M is equal to A by P. So everything we calculate and find out the slope. I energy slope is equal to I is equal to how much we got? 0.0208. So here next we need to find out the slope. We know that one, dH by dx. So that formula I having the bed of the channel, we know that one slope is 1 divided by 5/3. And next we need to find out the slope. This is IE, energy slope you got, that is 0.00. We having the formulas dH by A with respect to unit horizontal line. What is the changes height? dH by d, slope. What is the slope will change? Slope is equal to dH by dx. That equation we know, IB minus IE divided by 1 minus V square by GH. IE value we got 0.0208, and IB value they given in 1 in 4000 slope. The discharge through slope, the bed of the channel is having slope is IB is equal to 1 divided by 4000. So that answer is 0.00025. So you can write it 0.0025 minus 0.000208 divided by 1 minus V square. G is equal to 9.81 into H is equal to 5. So V is equal to Q by A. So is equal to 50 divided by B into H. 50 divided by B is equal to 20 into 5 is equal to 0.5. So dH by dx is equal to 0.00025 minus 0.0028 divided by 1 minus 0.5 v square divided by 9.81 into 5. Sorry, here there is not much space. So answer is 0.00023. That is the answer. Please note down the answer. 0.0023 answer. The final answer. The slope formula we are having dH by dx. So using that formula we find out the equations. What we have done, I will write the slow steps again if you are having confusions. We have done the first, we have done find out the slope, energy slope of the energy line, IE. So how we can find out? Using the formula V is equal to Q is equal to V into A. So V, using the formula C root of Mi. A we know area into B into, that is step 1. That we can write as step 1. Find out the formula M is equal to A by P, and here find out IE, and area we know that one value B into H. So we having the Q value, Q also valuing. So using that find out the IE value. We got the IE value, and next step 2, calculate IB value, and this one slope IE is equal to DH minus DX. So in that formula we are having IB minus bed slope minus energy slope 1 minus V square by GH. Using that we can find out the final I value. So that is the final equation, and they, using this equation, they find out the value of depth bed. So we got the final I value. The simple equations using that energy slope we find the slope of the water free surface in a rectangular channel of width 20 meter and the depth of the flow 5 meter. The discharge to the channel is 50 meter cube. The bed of the channel having slope 1 in 4000. Take the value of this constant C is equal to 16. This is very important problem, and it's very easy problem for finding out the bed, and this is one this kind of question will ask for your semester exam also. Please write down this, please practice this kind of problems from your textbook also. So it's very much useful, and this theory part what I have written and what I have given in the starting of your this video, that is very important for your exam point of view. So please note down all the theories in your notebook, and what I am giving in that video lectures, please follow up that all videos, and whenever I am explaining, you just write down in your notebook, and after that you refer and make it revisions, and that is very much useful for your reference for your exam. So that reason I'm telling it's please do hard work for your exam. You are having lot of time this time, so you can score well in your semester this time, because question this time you're getting more time to read. So and you're not getting much burden also, because one day you're having only 1 hour video, 1 or 2 hours video. You can refer it easily. So this is why I'm telling you, because before going to that one, gradual varied flow we have discussed about. What do you mean by gradual varied flow and rapid varied flow? I said is very slowly and suddenly it is increasing the rapid, and patapat increasing changes will happen in the flow. That is called rapid varied flow. And gradual varied flow, in the short distance, small variation takes place, but it will take more time to variation. For that is called gradual varied flow. Slowly variation takes place. That is called gradual varied flow. And And this is very much important for your right designing of dams, and in that and practical application it will take this will we are considering what kind of flow is there and what is the impact in the downstream side, everything we are considering this one, and gradual varied flow. And then one more thing is backwater curve and backwater flow, that we'll discuss about this one. What do you mean by backwater curve? That we'll discuss now. Backwater. Backwater curve. So this is the one where the application you just see that one. For example, this is the flow and the dam side upstream side flow and the surface of the earth, and this is the dam. This is the dam. This is the original flow, and here the gradually water will increase. You can see H1 gradually increasing, and here its overflow occurs. This is again H2, H3, H flow. It's gradually increasing. The flow is gradually increasing. H1, H2, H3 flow like this, gradually increasing. This is the final increase of water we can see in HL. So here what is we can say what x distance and unit change ಆದರೆ height ಅಲ್ಲಿ ಎಷ್ಟು change ಆಗ್ತದೆ. Here we can say dh by dx. It means with respect to dx means with respect to x, if it is x distance ಅಲ್ಲಿ ಯೂನಿಟ್ ಚೇಂಜ್ ಆದರೆ, ಇಲ್ಲಿ x distance ಅಲ್ಲಿ ಯೂನಿಟ್ ಚೇಂಜ್ ಆದರೆ height ಎಷ್ಟು ಚೇಂಜ್ ಆಗ್ತದೆ, then that we can find, we need to find out. So we know that IB minus IE is equal to 1 minus V square by GH. We are having this formula in gradual varied flow. We are discussing this formula now, IB minus I. This is the IB value, slope at the bottom, bed slope, and IE is the energy slope. IE, that one we can say that energy slope. So here what we need to discuss means dh by dx. What I said, dh by dx. dh by dx I said is equal to 0 if it is happens. When it will happens, ds will dx is equal to 0. So that we'll discuss here. So when the water height will not change, ನೀರಿನ height ಯಾವಾಗ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. For example, so this is the x distance graph, and this is y distance, h distance. This is h, and we can write it, this is 1, this is 2, and this is 3, this is 4, this is 5. Here x1, you can write it, this is x1 1, x2 2, x3 3, 4, 5, 6. So this is 1, and this is 2, this is 3, this is 4, this is 5, this is 5. So dh by dx, the change of x, how we can means change in length for unit distance. Dh by height for unit distance, how much will change. So dh by, it means we can say that one h2 minus h1 divided by x2 minus x1. So here what is the distance for x2 distance? What is x2 distance? For x1 what is the distance, and h2 what is the distance? This is the same height, flow is same. So h2 is 5 and h1 also 5. x2 is 2 and x1 is 1. So what will happen? 0 minus 1, it becomes 0. So dh by dx dh by dx dh by dx is equal to 0. It means that flow is called uniform flow. So there is no changes will happen. So that we can say uniform flow. So no changes will happen in backwater flow. So next, if when it is happens dh greater than 0, when it is happen dh by dx is greater than 0. When it happens dh by dx is greater than 0, so that you can write it in the gradual varied flow. We can say in that these things happens. This is 1 and this is 2 and this is 3 and this is 4. This is 1 and this is 2, this is 3 and this is 4 and this is 5. So we can write it here h2 minus h1 divided by x2 minus x1. So here what happens is it will change. x2 is 5 and this is h1 is value is 2 small volume and x2 is equal to 2 minus 1. So answer is 3 by 1 is equal to 3. So it is greater than 0. That we can say non-uniform flow or gradual. This is called the backwater profile. Okay. So this is become gradual air flow. This is a backwater profile. We can say this is a backwater profile. This is the conditions left line in backwater. And next one, when it comes dh by dx is less than 0. When it comes dh by dx is less than 0. So this conditions when it comes down, drop down curve. This is all a backwater profile. Okay, this is, you can write it backwater curve profile. This kind of profile will happen. Drop down curve. So here what happens, this is h and this is x. So 1 2 3 4. Here 3 will happen and 2, and here 1 2 3. So what happens, h2 minus h1, x2 minus x1, h2 here what happens, h2 is 3 lambs and h1 is almost 5. So here 2 minus 1, 3 minus 5, 2 minus 1. So that is becomes minus 2 by 1, so minus 1. So this is called gradually varied flow. This is also gradually varied flow. These two are gradually varied flow. In backwater flow, that is it's considering these two flows, gradually varied flow. And maximum height and minimum height for this one, maximum height minus minimum height. It means HL minus H1. That we can calling a flux. That we are calling call it as a flux. So this is a general backwater profile, how it is backwater is creating and how we can divide it, that one, different types of flows here, gradually uniform flow or non-uniform flow and gradually varied flow. This what kind of flow it comes, what kind of flow backwater creates, backwater profile creates, and this kind of profile will create, and downside or drop down curve also backwater curve, this kind of profile will create in backwater. So we'll go for backwater derivations, backwater equations. So that also we can solve it here. Next we'll go for backwater equations. So we'll solve one by one. So what we discussed about before, backwater. So what will happen here? Change in depth by horizon dz by dx. For example, how we can draw the profile here, backwater curves. So if we applying the Bernoulli's equation here, total energy lines. So this is one slope will create with respect to surface, which on upstream side of the dams. Slope will create with respect to surface. You can show it here. This we can write it IB, and this is the slope of the bund or slope of the canal, and we can write it here. This one we can write it Z. We know that one. We can call it as datum height, and another one, this height, we can call it as H. This we can pressure head, and one more height comes V square by 2G. That we can say an imaginary line. That we can say velocity head or imaginary line. So this we can call it as datum line. This one call it as datum line. This one is section 1-1. This one is section 2-2. So equation what we understand the Bernoulli's equation, applying the Bernoulli's equation here, that H is equal to pressure height. Pressure height means water height. That is same. We already explained P is equal to rho gs, so that reasons we are following that only. And if we are applying the Bernoulli's equation, here section 1-1 and section 2-2. Section 2-2. Here what happens? Here what is the energy is available here? The same energy here in that applied. But what happens actually in it will happen some energy losses, head losses takes place, because in the previous Bernoulli's equation they are specified like that only. It means P1 by rho g, P1 by rho g plus z1, z means datum height, and next v1 square by 2g, and in section 2 the same p2 by rho g plus z plus v2 square by 2g, v2 square by 2g. In that previous but modified Bernoulli's equation, some scientists are analyzed it and they find it out some head losses takes place. So now modified Bernoulli's equation, they are specified some head losses takes place. So that first Bernoulli's equation they are not considered head loss. After that they are considered head losses. So that is the equation is there. So here we are taking H P1 by rho g. I said that is a pressure head. So we can write it that one. H is equal to, we know that one, H is equal to P by rho g. So this one we can write H1, and this one is Z1 plus V1 square by 2G plus here P2 by rho g. We can write it plus this one I can write it H2. This one I can write H2 pressure head. Then Z plus V2 square 2g plus HL. So it means dz by dx here, dz by dx. If I deriving with respect to z, because it what happens no here, if I changing this one x direction, dz by dx means when it is unit changing with respect to x direction, and unit changing with respect to x direction, z will, how much z will change, that will data also change this changes after that we need to find out. So how we can find out that one? So for total length, what is the total slope will change, that we need to find out. For one length we can say, right, for IB means slope of the channel, bottom base channel, the changing, the datum changing with respect to dz by d and dz divided by dx. This I can write it 1. So we can write it for one length, IB means dx means unit length. So for one unit length, I can write for unit length how much will change, slope will change IB. What about total length? Total length means from here to here, CCL. What is the total length? What is the changes will happen? That we need to find out. So how we can write cross multiplication L into IB? So L into IB for that one. So we can write it here. The changes energy loss with respect to H, we can write it here. This one Z2, we can write it IB into L. So here I will rub this one. I will write it H1 plus Z1 for base IB into L plus V1 square by 2G is equal to HL plus this one IB into IE into energy level into L plus V2 square by 2G. V2 square by 2G. So I can write it here, this one IB minus, here I can write IB into L minus IE into L is equal to H2 plus, we can write it H2 plus V2 square by 2G sorry, here this is H2, sorry, and this one HL, we can write it energy loss. So here H2 plus V2 square by 2G minus H1 minus V1 square by 2G. So I can write L, this one I can write L, this one I can write it L into IB minus IE common is equal to, this one is energy loss at 2 and this one is energy loss at 1. So I can write E2 minus E1, E2 minus E1. So the energy loss, the backwater length equation, we can got it L is equal to, L is equal to E2 minus E1 divided by IB minus IE, IB minus IE. So here small correction what I said now, how it comes is this one H2 plus V2 square by the head losses, energy loss here. What is the losses takes place with respect to X? When it is, what is the losses takes place with respect to Z? What is the losses takes place with respect to E? IE and IB. This is IB and this is one IE. If you are having confusion, I will explain here. This is IE. So that we can write it here IB into L, and another one is, this one is IB into L, because here dz dou z by dou x, because means IB is equal to dou z by dou x. It means dou z by dou x means what mean by datum changes with respect to x, unit changes. When it is x unit changes, datum will also changes. So it means here I am adding one value, IB is equal to 1 unit. This one is unit and this one is slope changes. So it means for 1 unit, that is the IB will changes will happen, changes slope will happen. For total length, what is the slope? So that we can consider IB into length. For full length we can say. So same thing, 1 for energy slope I, for unit length for energy slope is IE, and what about for total length? So that we can consider in here. So if you are having any doubt, please text me for my personal number. I can write and I can explain you. If you are having any confusion, please let me know, because I will clear your doubts. Don't be confused and don't worry about that. If any question, if you are any doubt, is free to call me and text me. I can answer your questions and I can explain you with one more video also I can make it if you are having any confusion or any kind of doubt. And this is also very much important derivation and very easy derivation, so you can practice it in your home also. So that in this problem, in this derivation, we are having one more problem that we can solve in, then one more video will make it, in that we can solve it in that problem. So okay, thank you very much.